I'm Monish Mani P of URK25CS1080. This is my computer organization and architectures practicum number 8, DMA simulation, direct memory access simulation. Actually, to retrieve the memory access for the input and output source, the CPU has to involve in it. But the direct memory access will make the without the use of active use of CPU, the memory access can be accessed by the input output resources. So that is the core objective of this practicum. So in this practicum, we are going to follow this procedure: switching on the computer, opening the MATLAB on your computer, create a new script file. Then we are going to run this following code to see that input or output devices could access the memory directly. So we are going to initialize memory. Memory is equal to zeros, 1, 20. We are going to initialize memory in 20 locations, all set to 0. So initially the memory is equal to 0. Then for random values, for 5 random values that we are taking from the input output devices, and then we are displaying the initial memory, that is all or 0. Then show CPU is free, not moving data. Display CPU is free. DMA will not will handle data transfer. Then DMA transferring data into the memory. So memory 1 to 5, all the data are transferred into device data. So now we are going to display the updated memory contents. Updated memory after DMA transfer, display the memory. Show data received from input and output devices. The data received from the devices and the device data. This indicates the completion of the direct memory access transfer completed without CPU involvement and shutting down the computer. So in this initial memory, columns 1 through 17, 0 to 10, 0, 0, all are 0. Columns 18 through 20. So 1 to 20, all are 0. And CPU is free. The DMA will handle data transfer. So updating the memory after DMA transfer, 1 to 17, as we have given 5 random values to be stored in the memory. First 5 values are updated, and where other values are not updated. Then finally, what are all the values that are received from the device is also shown here. Thus the execution of this practicum is completed successfully with the code. And this is the extra suggested practicum question, evaluating how DMA proves system performance compared to CPU controlled data transfer. The same thing, the data size is given 10 power 6, which is nothing but a 1 million. Then CPU control data transfer is happening, and the direct memory like transfer, the block transfer is also happening. So if the DMA time is less than CPU time, the time for both is calculated. If the DMA time is less than CPU time, the DMA transfer is faster and improved system performance is given. Else, CPU transfer took similar to the took similar or the less time. So here is the output. CPU control transfer time 0.01, DMA transfer time 0.00001. 7 seconds. So DMA transfer is faster and improves system performance. So next question, we are going to demonstrate how bypassing CPU during data transfer saves time and power. So actually this CPU so in this practicum also we are going to initialize the data size and also the simulated data size. Then CPU controlled transfer is happening, and DMA like transfer is also happening. So the power we are going to power proportional that we are going to calculate is the main formula is CPU power is equal to CPU time into 50 assumed power unit, and the DMA power is equal to DMA time into, we will multiply with the power unit, and which is taking more power is considered as like more power consuming, whereas which is taking less power is considered as the best option. And also CPU, the direct memory accessing reduces less power consumption. So according to the output of the given code, we have got like DMA transfer time and also CPU transfer time. While CPU transfer time is high, so the power consumption of it is also high. So DMA always also reduces power consumption. The practicum is executed successfully. Thank you.